We're going to look at a normal distribution today. So a normal distribution is when we have a data set and all of the results create a bell shape. So we have this bell shape and we call it a bell curve. So a couple things to note about our bell curve. The data values are obviously symmetric, and then the center, that peak, is the mean. So your mean will always be at the center of your bell curve. Since it's symmetric, that means exactly half of your data values are to the left of the mean and exactly half of them are to the right of the mean. And then all 100% of your data will be underneath that curve every time. We have our mean, which is notated with this mu, and our standard deviation, which we've talked about. Those two values determine your location of your bell curve, how spread out it is, how high it is, how tall it is. So your data values definitely affect what your bell curve looks like. Here are three different little bell curves. We could have a really steep bell curve, we could have a really, really drawn out bell curve, or just kind of an average height bell curve. All of those, though, would have the mean in the middle and represent data. A really quick reminder, we talked about standard deviation and we said that it measures how far each data value is from the mean. So that'll be important to know because we have this 68, 95, 99.7 rule. And that means for any normal distribution that you have, if you are one standard deviation away from your mean, 68% of your data will lie within that range. If you go 2 standard deviations away from the mean, you'd have 95% of your data. And then if you get 3 standard deviations away from your mean, 99.7% of your data would lie within that interval. So here's a really rough sketch of what that means. So we have our bell curve. Remember, our mean, or our mu, is in the middle. If we go 1 standard deviation above and below, we get 68% of that data. Okay, if we go 2 standard deviations above and 2 standard deviations below our mean, that's 95% of our data. And then 3 standard deviations above and below would give us 99.7. You see there's not much on either end left over for data values. So we're going to look at a couple examples. The first one, we have a set, well, actually we're going to use this information for the rest of our examples, but we have a set of test scores that are normally distributed. They have a mean of 75 and a standard deviation of 4. So we want to know what percent of scores are between 67 and 83. I always sketch a picture so that it makes a little more sense. Drew a normal bell curve. 75 was our mean, so that goes at the center. And then a standard deviation of 4 means that if I go 4 units above and 4 units below, I would have 71 and 79. Okay? According to our rule, 1 standard deviation above and below was 68% of our data. If I go 2 standard deviations above, so 8 data values or 4 data values above 79, we get 83. And then 8 standard deviations, 8 units below our mean, or 2 standard deviations, we get 67. So the 67 to 83 range is 2 standard deviations below and 2 standard deviations above. And according to our 68, 95, 99.7 rule, that means that 95% of our data values are between 67 and 83. I want you guys to go ahead and try this one. What percent of scores are between 75 and 79? Then we're going to look at what percent of scores are between 79 and 83. So I drew my picture again. Here's 79 and 83. So we're going to start with our 71 to 79. So between 71 and 79, that's 86% of our data. Okay, that means between 75 and 79, hopefully you got 34% up above. So we have 34% of data values between 75 and 79. Between 67 and 83, we already said was 95. Well, we're not worried about the left half. We're only primarily worried about the right half of our data. So between 75 and 83, that'd be 47.5. Okay, I just divided both 86 and 95 in half to get these 34 and 47 and a half. Now, we're not worried about 75 and 79, so we need to take this 47.5 and subtract the 34%, and that leaves us between 79 and 83, we have 13.5% of our data values, or our test scores, I guess. Okay, what percent of scores are less than 83? This is the last example we'll look at. Here's our lovely picture again. Okay, we talked about 67 to 83 is 95% of our data. Okay, so we know at least 95% of our data values satisfy here, but we think there's more. That leaves us 5% on the outsides. Okay, since normal distributions are symmetric, we know that that 5% left over needs to be split between the left and the right half. So 5 divided by 2 gives us 2.5. So on the left half, there's 2.5% here, and on the right half, there's 2.5% there. So we're going to take our 95%, that's 67 to 83, and we're going to add the 2.5% from the left side because we wanted 83 and anything to the left or anything less than. So we have 97.5% of our scores are less than 83. You could also know that there's 100% of data values underneath this curve. And if you know that this is just 2.5% above 83, you could take 100 minus 2.5 and also get 97.5.